So let us look at the coding part now. Here we have the folder named dataset. When you see into the dataset, there are two subfolders, test and train. When you see test, there are three further subfolders are there which are holding the images. And these images, these folder names, it should be the label name. It should be the label name of the images that we are trying to classify. Same is the case with train. Three folders, each folder is having some images. So now first of all we will make a Google Colab file. Okay, so we have our Google Colab file here and we will give it a name, car brand classification. Here we will write a text to give an information about what exactly we are doing with the program. It is just I feel that it's a good habit. So car brand classification using partially trained pre-trained model. For demonstration, the pre-trained model is that we are going to use. Model that we are going to use is ResNet 50. And whole among the program, I will be using the TensorFlow documentation for reference of the codes. It is a good idea to use those codes it is a bit difficult to remember all of them. Okay, so first of all we need to mount the Google Drive so that we can access our folder. To access this folder, we need to mount our drive. So this is the way, mount drive. It will take a little time. Okay, so once this drive folder comes here, that means that the mounting is complete. Now we have to unzip the dataset is in zip format, so we have to unzip it. So command for it is unzip and we have to specify the path. To get the path, I will use this. I will navigate to the folder where I have stored it and here. Just do copy path and paste it here in quotes. See, unzip is complete. Now we will import TensorFlow as TF. Okay. Now we need to make the we will get the images. We have to read these images. We have to read and pre-process the images. So for that, first we'll make a data generator or image generator, and then we will pass the images through that generator. Now let us look at the documentation. tf.keras.image preprocessing. So when we go on the Google, this documentation will be there. From here we can directly get the codes also, code line also we can get it from here. So there are so many features here, so many arguments that we can give for this function or this image data generator. We will be using some of the specific ones that we require for ourselves. So directly I am going to copy this. and from here I'll take the ones that I require. First of all, I will require a rescale. I will rescale it to 1 by 255 because all the pixel value that I will be having, it will be from 0 to 225 only. 255, sorry. Then for data augmentation, I will be doing these two, horizontal flip and vertical flip. This I will set at true. Again for data augmentation, I am going to set use shear range and zoom range. For now I will set it at any random value. We can change it 0.1, 0.2. Okay. I can set rotation also. If you see here, we will have rotation also. So randomly I will set it at 50. This image generator, this is for train images because data augmentation we are doing on train images only. So I will name it as train underscore generator. Similarly, I will make a generator for test also. So test underscore generator, and I'll use the code. And in this case, we only have to do rescale. Rescale 1 by 225. Okay. So here our generator is ready. Now we have to pass our data through this generator. So for this we will check our documentation. We will get something here. I will search it, flow from directory. See, this is the code that we'll be using for passing it. So now train images, this will be stored in this variable. This is equals to train underscore generator dot flow from directory. And target size we are giving 256 by 256. One of the reason is because when we will be using our ResNet 50, generally the ResNet 50 pre-trained model is trained on that specific just 1 minute, I'll show you. tf.keras ResNet 50. When we see the documentation, this was trained on 224 by 224 by 3. This input shape is asked by ResNet 50. So just for the sake of it, for now, we will put the input image as 224. comma 224. Here we have to give class mode. Class mode will be categorical because we have 3 classes. Had it been only 2 classes, we would have given binary. So we can directly copy paste it from here. Class mode is categorical. That's all. To keep the program simple, I'll keep it this is only that I'll be giving. Now the directory, this will be the train generator. Sorry, not train generator, this will be the path of the images. So that path is dataset slash train. Now similarly for test images, I will directly use this code and I will just change the train to test. Here I made one mistake, here it should be test. So 64 and 58 images belonging to 3 classes. The file has been read here. Let's move on with our next step then. See, here when we see, here the image has been converted to array. This we have to keep it in mind. Now the next step is to make the model.